an example. 7.4 is basic concepts of probability. So we go from introduction to probability to basic concepts of probability. Good section names there. The next section is more basic. No, it's not. Not at all. Advanced basic concepts of probability. No, it's not. Consider the experiment of picking a card from a standard deck of cards. Find the probability the card selected is a dun-dun-dun jack. I would like you to do A and B, and then we're going to do C together. So part A, the probability of picking a jack. How many jacks are there in a deck? Out of how many cards total? 52. Good. And this reduces down to 1/13. How many threes are in a deck? 4. Out of how many cards total? So the probability is also 1/13. Part C, jack or a 3. Well, we saw the word or before in 7.2. Actually, also 7.1, but mainly in 7.2. Or, for the most part, means addition. In this case, or does mean addition because can you pick a jack and a 3 at the same time if you're only picking one card? No. So in other words, the event of picking a jack and the event of picking a 3 are bark, 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 nom, 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 bark, 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 nom, 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 bark, nom. Yeah, mutually exclusive. They can't happen at the same time. So when you have events that are mutually exclusive, you just add the probabilities. So the probability of picking a jack or a 3 is equal to the probability of picking a jack plus probability of picking a 3. Bark, 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 bark. Nom, 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 nom. Part A, what is the probability of picking a jack? Sure. What is the probability of picking a 3? Part B. So the probability of picking a jack or a 3. You could have also used the 1/13 numbers. It does not matter. This will reduce down to 2/13. Yep. So again, or for the most part means addition. For the most part. If you would, please do D, E, and F. Carefully. What's the probability of picking a heart? Right. So I'm going to write it as 1350 seconds, which is 1/4. And what's the probability of picking a face card? Which is 3/13. Good. Is that okay for D and E? That's what we just did. All right. F, heart or face card. Well, how is F different from C? Because you can pick a heart and a face card. So we cannot just add the 13 and the 12 because we'd be double counting the cards that are hearts and face cards. So in this case, or does mean to add, but since they're not mutually exclusive, we have to subtract out the overlap. Otherwise, we're double counting. Just like what we did with our Venn diagrams. We subtracted out the overlap from both numbers. So, still need the probability of a heart plus the probability of a face card, but minus the probability of picking a heart and a face card. So again, we have to subtract out here because we have an overlap. So the probability of picking a heart is 1350 seconds. The reason I'm using this one instead of 1/4 is because it'll make a common denominator. Probability of picking a face card is 1250 seconds. But we need to subtract out how many hearts are also face cards. 3 out of how many total? 52. So again, we cannot just add the 13 and the 12 because you're double counting the Jack of Hearts, Queen of Hearts, and the King of Hearts. What is 13 plus 12 minus 3? 22 over 52. And that reduces down to 11 over 26. Oh, it doesn't let me write there. Oh, I can't go out here? Oh, it's like Field of Dreams where if you get out of the field, you don't exist anymore. That's okay. 11 over 26. Watch that movie. It's a good movie.